Okay, for E and F, I have to make sure before I start analyzing everything that I take care of what is underneath my radical symbols, and that is that I have a number being multiplied by the x, and that needs to be factored off the x. I'm going to have to factor out that 1/2 or factor that 1/2 off of that x, and I'm going to have to factor the negative off the x over in F here before I start the problems. So let's go ahead and do that. I'm going to end up with 2 square root of 1/2 parenthesis x. Now this is where issues occur. When you factor out 1/2 out of that 2, you're really dividing that 2 by 1/2. And 2 divided by 1/2 is not 1. 2 divided by 1/2 is actually going to turn out to be 4. So when you factor out your half, you get x plus 4. And you just have to be careful of that situation. And then we have minus 3 still on the end. So now that is in the proper form to analyze and look at our shifting and our compressions and stretches. And over here, I'm going to have to factor out that negative off that x. So I end up with negative 3 square root of negative x minus 3, and then plus 5 on the end. Okay, so let's take care of our shifting. I have a minus 3 on the outside, which is a downshift. I have a plus 4 on the inside, which is a left shift. It's opposite of what you think. I have on the inside of my function a 1/2 being multiplied by the x, and instead of having that, it's going to do the opposite, and it's going to multiply your x by 2. So that's going to times the x by 2, and then on the outside here, I'm multiplying my function by 2 on the outside as well, and that's going to double my y value. So it's going to take my y value and times by 2, and like I said down here, it's going to take the x value and times it by 2. And I think that's everything. On the inside of your function, it's always opposite of what you think is going to happen. Instead of adding 4 or moving to the right 4, you go left 4. Instead of having your x, you actually double your x. It's opposite on the inside. On the outside of the function, it is what it is. If you see a minus 3 on the outside of your function, you go down. If you see a times 2 on the outside of the function, you times your y by 2. All right, let's see if we can graph this. The regular, I'm going to just graph the regular function first. The parent function, which is just the square root of x, which is 0, 0, 1, 1, 4, 2. Okay, and then we're going to move our function now to the left 4 and down 3. So 1, 2, 3, 4, down 1, 2, 3. That's our new origin. It's our new xy axis. You're going to literally just pretend that this is the original xy axis, and you're going to ignore the old xy axis. I'm going to ignore the actual xy axis. Okay, so this is like a double shot. Instead of going over 1, up 1, we're going to go over twice as much, which would be 2. And then we're also going to be going up twice as much, which would be 2. So instead of over 1, we go over 2. Instead of up 1, we go up 2. I think I just put that in the wrong spot. So instead of going over 1, we go over 2. Instead of going up 1, we go up 2. It's double on both. All right, and then normally we go over 4, up 2, but we're going to double each of those movements. So instead of going over 4, we're going to go over 8. 1, 2, 3, 4, 5, 6, 7, 8. So instead of over 4, we go 8. Instead of up 2, we're going to go double that amount, which is up 4. 1, 2, 3, 4. Okay, so the original point was 4, 2. We double, we get 8, 4. And then we can go ahead and graph that. And so the function that's in red, the parent function, is not actually part of the answer. And then you don't really need the dashed lines for your new XY axis, but I'm just going to leave them in. I don't feel like erasing them. And let's go on to this next function right here. And once again, it's the same parent function. It's just the square root function, and that's going to be 0, 0, 1, 1, 4, 2. But we have some things going on here. We have an up shift of 5, a right shift of 3. We have a stretch on the Y, and we have like a double reflection. So not only are we going to reflect over the x-axis with this negative here on the outside, but we're going to reflect over the y-axis as well. So stretch the y of 3, reflect over the y-axis, and out here reflect over the x-axis. So there's a lot going on. Let's go ahead and take care of the easy part, which is the shifting. So I'm going to go to the right 3, 1, 2, 3, and I'm going to go up 5, 1, 2, 3, 4, 5. And then this is my new origin. It's my new XY axis. I'm going to ignore all the numbers on the old XY axis and pretend that this is the actual XY axis. And then my function, instead of going over 1, up 1, I'm going to go over 1 and up 3 because my y values are tripled. But not only do I have to triple my y value, but I also have to reflect in 2 directions. I have to reflect x and reflect y. So I'm going to, instead of going over and up, I'm going to go down and back. So back 1 and down 3. Reflect y, reflect x. Reflect y-axis, reflect x-axis. And then instead of going over 4, down 2, I'm going to go over, instead of going left 4 and down 2, I'm going to go left 1, 2, 3, 4, and I'm going to triple that amount. So that's 1, 2, 3, 4, 5, 6, and then I'm going to put a dot. Okay, so back 1, down 3, back 1, 2, 3, 4, down 6, 1, 2, 3, 4, 5, 6. Looks good. And then my graph is going to swing around like that. And then once again, you don't really need this red graph. That's just to show you the normal original parent function.